Welcome to This Explainer. Today, we're unraveling a massive ecological mystery, and it's one that is hiding in plain sight inside billions of data points. We're going to be looking at the world's bird populations, the modern smartphone tools we use to track them, and a fascinating mathematical quirk that revealed a gigantic blind spot we literally didn't even know we had.
So let's just start with a basic question. Can a smartphone app actually accurately count the world's birds? I mean, it sounds simple enough, right? But citizen science apps like eBird are currently being used to estimate the abundance of an absolutely staggering 92% of all avian populations globally. That is almost the entire bird world. With such a heavy reliance on crowdsourced data, scientists really had to stop and ask a critical question. Is this data actually reliable, or are our own human habits completely skewing our understanding of the natural world?
Section 1. Counting the world's birds. The power of citizen science.
It is a truly monumental task to track nearly 9,700 bird species across the globe. We've essentially outsourced a huge chunk of this work to everyday people, and honestly, apps like eBird have been a real game changer for studying avian populations. Right now, millions of bird enthusiasts all over the world are documenting their sightings on their phones. It's an unprecedented influx of data. But researchers looking really closely at this dataset started to get suspicious. They had a hunch it might contain a hidden structural flaw.
Section 2. The economics of ecosystems. Borrowing tools from Wall Street. To test the quality of all this bird data, scientists did something brilliantly unexpected. They actually borrowed a concept straight out of corporate economics. It's called the granular hypothesis. In the financial world, this theory suggests that a handful of massive, giant companies have a disproportionately heavy impact on an entire economy. This completely counters the old statistical belief that the effects of individual firms just kind of average out over time. Basically, a few mega players don't just participate in a system, they completely dictate it.
So the researchers decided to treat bird ecosystems exactly like an economy. They asked, do a few hyper-abundant bird species dominate their environment in the exact same way a few megacorporations completely dominate the stock market? Because if they do, failing to account for these avian corporations could completely misrepresent our entire ecological model.
To track this down, the researchers had to use some seriously heavy-duty math. By analyzing species abundance using power laws and Pareto exponents, which are basically mathematical tools used to measure extreme inequalities, they searched for a very specific threshold. They were hunting for the granular size, basically the exact number of species throwing off the ecological curve before the wild variations finally stabilize. It's like finding the exact number of weights tipping a giant scale.
Section 3. The Special 13. Finding the granular size.
Let's look at the results of their statistical investigation to see exactly how many corporate giants exist in the avian world. And honestly, the result is jaw-dropping. Out of roughly 9,700 bird species studied, the mathematics revealed that exactly 13 bird species represent the granular size of the entire distribution. Not 100, not 50, just 13. These 13 specific species are the heavy hitters, massively skewing the data for the other thousands of species.
To really put that into perspective, look at the decay rate of abundance. Notice where the blue line tracking the decline in species actually flattens out and rises to the 0 mark. That flattened area represents a normal, bell curve average, and mathematically, it happens perfectly right between the 14th and 15th species. This shift proves our magic number of giant, megacorporation species is exactly 13.
Okay, so who are these corporate giants of the avian world? Coming in at number 1, we have the incredibly common house sparrow with over 1.6 billion birds. The European starling takes second place at 1.28 billion, and the ring-billed gull sits at 1.22 billion. These three species alone have populations so staggeringly huge that they totally dominate the dataset.
Section 4. The urban plot twist. The ChatGPT verification. But knowing the number is only half the mystery. Why these specific 13 birds? And what does their sheer dominance actually say about our citizen science data? Well, to figure this out, the researchers actually posed this exact mystery to ChatGPT, just to see if an AI could spot the hidden ecological link connecting these top 13 species.
And the AI's answer? It was a total paradigm shift. It hit the nail on the head. They all live where we live, cities. This right here is the major plot twist of the data. These hyperabundant birds
aren't necessarily a perfect reflection of wild nature. They are a reflection of urban environments. We basically discovered that our billion-bird database is heavily weighted by everyday people just logging pigeons on their way to the grocery store.
The bias becomes painfully obvious when you compare them. The special 13 primarily inhabit urban and suburban areas, but the very next 13 species on the list, they occupy completely diverse wild habitats like wetlands, dense forests, and coasts. The app data simply isn't showing us the whole natural world. It's showing us a massive sampling bias. Because let's face it, human beings just prefer to use their smartphones where they already live, where they commute, and where they walk their dogs.
Section 5. Fixing citizen science, correcting the lens.
Now that we know this incredible dataset is heavily skewed by our own urban backyards, how do we fix it? We certainly can't just throw away millions of incredibly useful data points. Well, the researchers outlined several actionable strategies to balance the scales. First, we can integrate data from professional surveys to get a more balanced view. We also absolutely need to incentivize birdwatching in rural, less populated areas to counter that massive urban bias. And of course, we can use sophisticated machine learning algorithms to mathematically correct for our uneven sampling efforts.
The researchers themselves note, and I'll quote them directly here, interestingly, the advice to use a hierarchical modeling framework to explicitly characterize the sampling process and account for bias was exactly what our work did. Basically, applying rigorous statistical models is the absolute key to fixing this. Ultimately, this explainer highlights that we can absolutely still use the massive power of citizen science to understand our planet, provided we use clever math to correct for our own very human behaviors.
Which brings us to our final question today. If our data is mostly gathered from our own backyards, what are we entirely missing out there in the wild? I'm going to leave you with that thought to ponder as you consider how the everyday tools we use to observe the world fundamentally shape the reality we end up seeing. Thank you so much for joining me for this explainer. Keep questioning the data, and I'll see you next time.